This one says a pendulum with length 2 meters is pulled such that the angle between the starting point and the equilibrium position is 20 degrees. It says the pendulum bob has a mass of 2 kilograms. What is the velocity as it crosses the equilibrium position? So it doesn't look like you're given a whole lot of information there, but you are given more than you realize. This is going to be a particularly math-intensive question. You've got to remember all the math that we've used so far, as well as the conservation of energy. So we are basically looking for the velocity, and we're looking for the velocity of the object in the downward position. Now, I know that I raise the pendulum bob such that this angle right here is 20 degrees. So I'm going to go ahead and just pull this out real quick, and I'm going to say, okay, that means I have a 20-degree angle, and I also have this right here is the length of the string. If you look, the string on the pendulum bob isn't going to change its length as it's moved up. So this right here is 2 meters. So I have the hypotenuse of a triangle, and I have the angle of a triangle, and that allows me to calculate the sides of a triangle. This side of the triangle has no real relevance, but this side definitely does. So I want to go ahead and calculate this side right here. Most people think, okay, well, it's going to be sine because I'm trying to solve for the y component. Well, that's usually when you have this angle right here. So you have a couple of choices. What I like to do is I like to say, okay, if this is 20 degrees, this is 90 degrees, that means this has to be 70 degrees. And what I can do then is I can say, okay, sine of 70 times 2 would give me this side right here. So let's go ahead and do that real quick in our solution. We say 2 times the sine of 70. And you can see how I got 70 is just 20 and 70 have to add up to 90 because you have a 90-degree angle here. So if I have that, 2 times the sine of 70, and that gives me 1.88. So this side of the triangle is 1.88. And you say, okay, well, what does that have to do with anything? If you look back to our original drawing, this is the triangle that we're talking about. We solved this as 1.88. But the height, the difference in the height between these two objects is this distance right here. Remember, if the entire string length is 2, and then this one has a vertical position of 1.88, you can now solve and you can say, okay, well that means that the height, the discrepancy between these two things right here, would be equal to 2, which is the whole length of the string, minus this 1.88, which would give us a value of 0.12 meters. Okay, that's the tough part of this. Once you have that, the rest of the question is very, very easy. Conservation of energy, E1 equals E2. Talking specifically about potential energy, because gravity pulls it down. And then you also have 1/2 mass velocity squared, which is the kinetic energy. So we can say mass cancels out. We have gravity, which is 9.8, times the height, which was the tough part, finding 0.12. And then on the other side, we have equals 1/2 what I'm trying to find squared. So what we do is we multiply both sides by 2, and when we do that, we get 2 times 9.8 times 0.12, and that gives us a value of 2.352. Remember that equals v squared, so we have to take the square root of both sides, and when we do that, we get 1.53 meters per second.